Let's go ahead and get ready for our Chapter 7 quiz. I'm going to go over the review. On number 1, we're adding two polynomials, a trinomial and a binomial. When I do this, I'm going to take all my like terms and put them underneath over here. So since this ends in an x squared, I can combine it with this x squared. I'm going to add 7x squared here. And since this is a negative x, I combine it with this negative x. I have no constants over here, so that's all I'm going to be able to do. My negative 2 comes down. When my signs are the same, I find the sum. So I'm going to add these together, so give me a negative 2x. And when my, then I'm going to have 7x squared plus x squared. That's going to give me an 8x squared. So my answer should be 8x squared minus 2x minus 2. And there it is, 8x squared minus 2x minus 2. All right, let's go to number 2. Number 2, I got a negative sign. So all of these signs will become the opposite. A negative times a negative will make a positive 4p to the second power. A negative times a negative, again, will make a positive 0.1p. And a negative times a positive will make a negative 3. Now I'm going to move everything over here. And remember, now we're adding all this together, right? This is no longer negative. So we're going to combine this with this over here. I'm going to take my positive 4p to the second power, put plus 4p to the second power. I'm going to take my plus 0.1p and add it to plus 0.1p. Then I'm going to take my negative 3 and put it over here. And then once again, combine everything. 3 minus 3 is 0. I'm not going to put that down there. 0.1 plus 0.1 makes 0.2p. And 4p to the second power plus 0.7p to the second power makes positive 4.7p to the second power. And let's see, this was positive, so we're going to be adding this 0.2p. All right, I'm just going to make that 0.2p just a little bigger so it doesn't look like an exponent there. Okay, let's see how we get. Over here, 4.7p to the second power plus 0.2p. All right, they did it going this way, and it's the same thing. We're combining our like terms using parentheses. I just stacked it. As you can see, my work seems a little bit more neater and not as much writing. Let's go ahead and go to number 3. Number 3 says find the product or quotient. If I find the product, that means I'm multiplying these. So instantly, I'm going to say this is a y times a y. That's going to give me, and I'm going to use the FOIL method here. That's y squared. Then I got, well, y times 1. Well, that's going to give me plus y. I don't put 1 in front of y. And then I'm going to take 4 times y. That's going to give me a positive 4y. And then I'm going to take 4 times 1. That's going to give me a positive 4. My like terms are y, a positive y plus 4. That's going to give me a positive 5y. Everything else comes down because there's no other like terms to go ahead and mix with them. And my answer should be y to the second power plus 5y plus 4. And there it is, y to the second power plus 5y plus 4. All right, let's go to number 4 now. Number 4, once again, I'm multiplying these together. So I'm going to take this negative times, z times z. That's going to give me z squared. Then z times a positive 6. That'll give me a positive 6z. Then I'm going to take negative 2 times z. This will give me a negative 2z. And I'm going to take negative 2 times 6. That'll give me a negative 12. My like terms are 6z minus 2z, which gives me 4z. And everything else comes down like before. So my answer should be z to the second power plus 4z minus 12. And there it is, z to the second power plus 4z minus 12. All right, let's go to number 5. Well, number 5 is more of the same, except we're mixing a binomial with a trinomial. So I'm going to have n times n squared. That's going to be n to the third power. And the other way to do this, I'm going to try that other method we learned in class just to see if it's would come out a little easier. I can take this and make it times n minus 3. Okay? In other words, I got rid of this, and I'm putting it over here like a multiplication problem. Now, 4 times negative 3 would be negative 12. 3 times negative 2n will give me negative 6. I'm sorry, positive 6n. Because a negative times a negative is a positive. And then n to the second power times negative 3 will give us negative 3n to the second power. Now we have to multiply n to everything. N times 4 will be a positive 4n. And n times negative 2, well, that would be a negative 2n to the second power. And let's see, we'll have n times n squared. That's going to give us n to the third power. All right, so now we bring everything down. That was pretty easy. This is going to give us a negative 12. This will give us 6 plus 4. That's positive 10n. These are both negative. When my signs are the same, I find the sum. So this would be negative 5n to the second power. I got to clean that up a little. And then I'll bring down the n to the third power. So my answer should be n to the third power minus 5n to the second power plus 10n minus 12. Let's see how we did. Here we are, n to the third power minus 5n to the second power plus 10n minus 12. That's exactly what I had over here. All right. I wish I would have did the work over here. It would have turned out a little neater, but can't do nothing about that. Let's go to number 6 now. Number 6, this is a division problem. So this time I'm going to remember that I'm dividing every one of these by h. So really this is like negative 4 h to the fourth power divided by h, right? And we're adding 6 h to the third power over h, and then we're subtracting 2h to the second power over h. All right, and we remember the rules. If my base is the same, I'm allowed to subtract here. So this would be 4 minus 1. This would give me a negative 4h to the third power. This would give me a positive 6h to the second power, and a negative 2h, and that's it. I don't have any power there because 2 minus 1 would be a 1. Let's see how we did on that one. As you can see, we have negative 4h to the third power plus 6h to the second power minus 2h, exactly like we said. All right, let's go to number 7. This one says use the special product pattern to find 41 times 39. Now, if I remember right, we're going to have to remember that this is really equal to 40 plus 1 times 40 minus 1, right? Okay, 41 equals 40 plus 1, and then we're adding, right? 39 is 40 minus 1. And now this is going to turn to 40 plus 1, right? And 40 minus 1, okay? And that's going to be 40 times 40, that's 40 squared. And then we have 1 times negative 1, and that's going to be a negative 1 squared. which really means -1, right? You might be thinking, what happened to the numbers in between? There's no letters here, so we really don't have that to worry about. There's no variables. So now we have 40 squared. That's going to be 1,600, because 40 times 40 is 1,600. Then we have 1 times 1. All right, and if you're thinking, hey, you forgot to make it -1 times -1, wrong. Remember that there's no parentheses here. So that square is only to the 1. So that's 1 times 1, which is 1. The negative stays there. Now we have 1,600 minus 1, which gives us 1,599. All right. Next is number 8. It says the cost in dollars of making n wreaths is represented by 7 plus 8n. Now the cost in dollars of making n table centerpieces is represented by 5n plus 5. Write a polynomial that represents how much more it costs to make n wreaths than n centerpieces. Okay, so we've got the two polynomials here, right? And we realize there's like terms there. And they're talking about how the cost in dollars of making n wreaths, in other words, the number of wreaths, is represented by this, right? And the cost in dollars of making n table centerpieces, that's what's going to be here, right? Is represented here by n being the number of table centerpieces. So that when they say write a polynomial that represents how much more it will cost to make wreaths than centerpieces, you're talking about a subtraction problem here, right? So we're taking 7 plus 8n, and we're minusing 5n plus 5. And remember, we're going to take this negative sign, right? And we're going to apply it to everything here. So negative times a positive will give us a negative 5n, and a negative times a positive, right, will give us a negative 5. And now we can combine this, right? We're going to bring it underneath the first, and we're going to bring the 8n in front. That's all they did over here. They brought this here, and they brought this over here, okay? And then they brought it on down, and now you have 8n plus 7, and now you have the negative 5n minus 5. Well, 7 minus 5 is 2, 8n minus 5n is 3n. So the answer is 3n plus 2. All right? Let's go to number 9. Number 9 says solve the equation. There should be a number 9 over here. I apologize. Yeah, that's an ugly 9, I know. So now it's saying solve the equation. To solve this, we're going to go ahead and put everything. We're looking for those roots, right? So this is going to be 3t is going to be equal to 0. And we're going to divide this by t, or 3, excuse me, which means we'll divide this by 3. And that's going to give us t equals 0. And then over here, we're going to have t plus 2 equals 0. And we know to solve that we'll minus 2 from both sides. That's going to leave us with t equals negative 2. So our roots are 0 and negative 2 for this one. And you can see over here, that's exactly what they did. Took 3t is equal to 0. They divided by 3 and got t as 0. Over here, they took t plus 2 equals 0. And then they subtracted 2 from both sides and got negative 2. The roots are 0 and negative 2. All right, let's try number 10 here. And this time we're going to have to move some things around. I'm going to remember that I can go ahead and subtract 2 from both sides. I'm going to do the work over here just so it doesn't get in the way, hopefully, of what they show. And the first thing I'm going to do is subtract 2x from both sides. When I do this, I'm going to be left with 4x squared minus 2x equals 0. Now I can go ahead and find the, I can use my greatest common factor, and I'm going to factor out 2x. I'm doing this because I know the biggest number that goes into 2 and 4 is 2. And I know that x squared is really x times x, and well, x is really just x. So what do they have in common? 1x each, right? So that's where I got this x. And now I'm going to bring everything that's left over. 2x times what will give me 4x squared? Well, that's going to be 2x, right? Because 2 times 2 will be 4, and x times x will be x squared. And then what times 2x will give me negative 2x? Well, that would be negative 1, right? And now I'm going to solve it the same way we did over here. I'm going to take 2x and put it to 0, which means we'll divide by 2. And of course, that's going to give us x equals 0. Then over here, we're going to take 2x minus 1 equals 0. And we're going to add 1 from to both sides. That'll give me 2x is equal to 1. And then we're going to divide by 2. And this is going to give me x equals 1/2. So our roots are going to be 0 and 1/2. And here we go. Just like I said, they subtracted 2 from both sides, leaving it with 4x squared minus 2x, right? Equals 0. They factored out 2x, just like we did here. They put 2x to 0, and they put 2x minus 1 to 0. They use inverse operations to solve for the roots, and x was 0, and x was 1/2. All right. Looks like that was all of the work. Looks like I'll see you in class for grading. Well, not for grading, but for review. I think there's going to be an easy test for you guys, or a quiz for you guys to go through. See you in class. Bye.